Right here. Hold on.
How should I stand?
Like that.
You're on. You're on. So, hello, this is one of our TAs for a robot. He's an in-class TA. Do you want to introduce yourself?
Yeah, my name's Lincoln. This is my second time TAing and my first time doing it for the FEH robot competition, and it's a lot of fun.
What do you do as your job as a TA? What does that entail?
Yeah, day to day, it's a lot of just helping students, answering their questions, grading, explaining grades to them, anything they might be struggling with, just clearing it up.
How do you interact with the robot course? Like, how do you help your students with that?
The robot specifically is a lot of helping them get a conceptual understanding of these components. A lot of the times they've never used them before, so just giving them a little bit of experience. Also, it can just be helping them with the design process, giving them a little bit of knowledge and just something to work with as they start the competition. And we have Open Lab as well, where we help students with their testing and working out kinks on their design throughout the semester.
Sweet. Thank you so much for your time.
Okay, cool. So we're with team. What do you guys? Table 20. All right, table 20. Walk us through. What's your project?
So we made Minesweeper in MATLAB. As you can see there, we took the classic visuals, put that all together, added our own twist, and have some variation there. You can change the height and width of the game board.
Nice.
Fully functional, just as the standard game works.
So I'm gonna ask you guys, why did you create this game?
Want me to explain this one? Yeah.
Okay, so kind of a delinquent to me, but during in high school, which he's a senior in high school right now, so he's still kind of doing it. But in study lab and any of my free time, if I was bored, I would play Minesweeper. It'd pass the time, it'd make a boring class go by quicker, and it's just a good time. So we thought, hey, we got an opportunity to make a game, we'll make a game that we love.
All right, then tell me the best thing about creating this project. One word.
The friends we made along the way.
One word?
You got something better?
You can use 2 if you want. I'll give you that.
Can we push it 3?
Be nice to me. Sure.
Okay.
Removing redundancies.
Okay.
Yeah.
That's 2 big words. Nice.
Sweet. Thank you guys so much.
Optimization.
If you guys want to learn more about Table 20, stop by. or why you chose to judge. I'll frame it like that.
My calling.
You cool? Okay. Guys, welcome back. So we have Bethany over here. So Bethany is a former TA for the ED and FEH. So Bethany, you're over here. You're invited as a judge. What are you looking forward to seeing?
I'm looking forward to seeing all of the robots to see what the students did this year. So I was a TA last year, so it was a similar course. So I'm just kind of curious to see how the students are going to approach it differently, what they're going to do similarly, and just to see how they take the course this year. Because I noticed they changed a little bit of the vinyl, so it'll be fun to watch.
Nice. She notices the changes in the vinyl. That's how involved she was with this project. Okay, so then I'm going to ask, kind of based on that, why'd you come back and judge?
I came back to judge because I'm still a recent graduate. There's still a lot of people that I know around here. I wanted to see what the program has done, how it's changed. Nice. I'd heard just through the grapevine a little bit of changes in the program, so I wanted to see what was new. And I always liked it. I have a soft spot for FEH, so I just wanted to come back.
That's what I like to hear. Okay, thank you, Bethany. Appreciate you telling us, and she's got to go to judge.
Oh yeah.
Good run, guys. Sound on? Did you say on? Sorry. Should we back this up or should we keep it? Oh, that's even better. Sorry, Antonio.
What's up?
Okay. Little quick interview. Sounds on, right?
Alright. Speak on right there.
Yep. So, hello. So, Antonio, tell me, what is your role on this course?
I reset it.
Nice.
Yeah.
And what do you enjoy about it?
It's fun to flip the levers back up and then, you know, the stamp
That's what I like to hear.
itches a spot in my brain.
Do you feel the energy that the students have when
Yes,
they're over
gonna
here?
pump them up for the final
Pump 'em
four.
up.
Can't wait for 6 o'clock.
6 o'clock. You heard it here. Oh shit. You heard it here. 6 o'clock. Final four.
I was betting on the students. Are you guys?
Alright,
People
starting
are awesome.
now, you will have 1 minute to set up your robot. Do everything except your final starting action. Give me a thumbs up when you're ready. Your minute starts now.
My bad.
Put the password. Thumbs up. Ready to go.
This is round sound 2A. Do your final starting action now. Do not touch your robot again until it starts it.
How did it work?
Nice position.
I mean, you don't. You're allowed to. You can leave if you want.
Nice.
Oh, it's still going. Yeah, you can pick it up.
Nice.
Sometimes the podium will be cut off with huh? They hit the kill switch and it was still going.
We just witnessed. Good job, well done, John. Okay.
That was epic. Go interview.
Guys. We're here with the live stream right here, Team A2. You guys just had a marvelous comeback. Tell us about what you were going through.
We knew it was going to happen.
Yeah. Easy. That's what I'd like to hear. All right, well, thank you guys. Congratulations. That's good.
That's why we do these runs. Comebacks.
I really want to interview teams before, but I feel like I'll freak them out. What do you feel? All right, we're going. We're climbing.
We're getting back. Back to work.
After this. Should we?
Alright, attention passengers, welcome to Brutus International Airport. You will have 1 minute to set up your robot, do everything except your final starting action. Give me a thumbs up when you're ready. Your 1 minute starts now.
What do you mean? No. I meant, should we park over there? Like, put the stuff over there, and then we record from that angle. Okay. That's really true, actually. And we designed them so that they're all fair and they're all the same.
Alright, this is round lesson 2A. Do your final starting action now. Do not touch the robot again until instructed. Grab to sit down next to the door, so give me a thumbs up when you're ready.
We get the George team started.
I see thumbs ups.
Alright, the kiosk button light is blue, the fuel lever is A, the match will begin in 3, 2, 1.
That's a good sign. That's what we aim for.
Good ball.
Oh my god! Please. There's one job.
Well done. What a run. What a run.
Okay, I'll try this one.
The hidden software. The hidden extra. The hidden.
here. Making it much harder. If you get 100, you can just accept that. Oh, coming back. Nice.
You missed something. Did you press the red light? I don't know what somebody really asked me.
Good job, well done. Congratulations. You guys ready? Yeah. All right. Let's meet here, E9. So, guys, you just had a perfect run. You were the first people to finish. So talk to me. What's going through your mind?
I'm feeling very excited. I thought that was a great run.
Yeah, really nothing much. It went exactly as we planned it to, and now we can kind of just relax because what happens in the final happens, so.
Nice. I noticed that you guys' name was First Round Exits.
Yeah.
And can you walk me through why you chose that name?
I think we just kind of wanted to create a juxtaposition between our final result and,
So you knew that you're going to be cooking like this?
I mean, I wouldn't say that.
No.
But
we couldn't really think of a name, but, it was really funny, so.
Yeah. Okay. Well, I'm glad, guys. Congratulations.
All right, thank you so much.
Let's be quick. Want to get interviews from live stream?
Not especially, but if it's, what are you going to ask me?
Yeah, so we start here when that light comes on. They have to hit this button.
Hello, guys. What's up?
We can do any of these.
As long as you ask me questions.
All right. Now we're here with Paul Kling, who is leading all this. Thank you for being our captain.
So I'm happy to be here today.
So please walk me through what's going on here. How's the energy feel, and what are you feeling right now?
I'm pumped up. I think the crowd is pumped up. The teams are pumped up. Everything's going really well today. Exciting runs, lots of perfect runs, close finishes. I'm looking for a really, really excellent Final Four.
That's what I like to hear. So tell me, how does it feel wearing that headset and commanding all of these robots?
I'm really just a mouthpiece. People are telling me the things to say. The TAs are handing me things. I just say what people give me. I'm not really doing too much here except doing a little bit of broadcasting. It's all the TAs today.
Well, thank you so much. We really appreciate that shout out, guys. Paul Kling leading this. Thank you.
Sure.
We're getting back here. Sweet. Okay. Here we have Alex, a TA who Paul just shouted us out.
Awesome.
So we have him working back here in the pits, and he is on software duty. So tell me, what is your role here?
Yeah, so I'm the RCS lead, and essentially what we do is we take in a bunch of information coming from the course. tell me to be louder. We're going to take in the information coming in from the course, and we essentially visualize it. So this is essentially what allows everybody to see what's going on in the courses, see the tasks that have been completed by the teams, and see time, scoring, all that kind of stuff. So it's pretty important considering we need to show the entire audience what's going on. So yeah, it's good. What's up? What else about it?
You seem like the perfect person to be running this. How do you feel in this scenario? You know, this is your responsibility.
Oh, it's good. I mean, we've had a lot of work to do on the software side. A lot of changes happened to the program within the last year. So a lot of work had to go into that. But it's good that everything seems to be running. Everything seems to be good. Pretty much no problems with the students trying to connect to our system. So yeah, I mean, it's going fine.
Cool. Thank you, Alex.
Appreciate it. Thank you.
Okay.
All right, sweet. Okay, guys, we are here with Jillian, and she's gonna walk us through what is going on here on the robot course. And we have this little video as a background. This is our time lapse of us setting this. So, Jillian, please tell us, what is your role?
So my main role today, I've been a course resetter. So after every single round, one, I make sure that the students are ready to go, ready to run their robot, and then after they're done, I go through and put all the tasks back where they should be, and then make sure their score is correct, and make sure that the students are like getting out of everywhere safely, and that we're running really smoothly.
Sweet. Okay, so my next question is, how does the vibe feel around here? You know, what's the dynamic?
I mean, right now we're on a break, we're watching our video, so it's kind of calm, but it's been pretty exciting. We had a major upset earlier. 2 teams finished, 100 points, ready to go, just came down to time. So I think it's been pretty exciting, high energy. I'm hoping it continues. We're about to go into the final rounds, so it should be exciting.
My last question is, what are you looking forward to most in the final round?
I'm really hoping we get close races. Like, I'm hoping we have multiple hundreds and it just comes down to that time again. That's what makes it the most exciting. The students get really into it. It'll be great.
Sweet. Okay, you heard it from here. Jillian, thank you.
Yeah.
All right, we have our co-captain over here, so please, if you can introduce yourself and tell us what's your role over here.
Yeah, absolutely. So my name is Jay Davidson. I'm the lead GTA for FEH, the program that we're doing the robot course for. Over the course of the year, I've been involved in helping build the course, get everybody ready and knowledgeable about what's going on, making sure everybody knows what job they're doing. Today, I've had the pleasure of following around Paul Klingen all day, our course coordinator. I keep him informed on who's winning each round, which teams are coming up next, when we're taking breaks, stuff like that, schedule for the day. So I'm his co-pilot for the day. And yeah, I'm just excited to see what happens next. Right now, I got 2 teams coming up in the final. We got E1, Robooligans, one of my teams, and then E9. First round exits, apparently they didn't do that, so they're in the final round right now. Looking forward to seeing what happens.
You know, it's funny, we got an interview with first round exits when they just won this round.
Yeah. They're great.
I'm glad we get to see both sides of what's going on.
They set their expectations low, and now they're just doing amazing. They made it all the way. They've really been peaking over the last week. They've been getting perfect runs pretty much every time. So I'm excited to see all their hard work paying off. They've been putting in lots of hours. Same with E1. They've been doing great. Robooligans, one of my favorite team names. They've just been doing great. I'm really proud of my teams and everybody else here too. Congrats to C2 and A2. C2's looking scary. They got some quick runs every round so far. They're going like under 40 seconds, perfect runs. So I'm excited to see what happens. I think it's going to be a close race.
Sweet, thank you so much.
Thank you, Jay,
Yeah,
so
thank
much
you
for giving
guys.
us insights. right, we're live. Okay, we have table Z, you guys are Z8, right?
Yeah,
okay.
13.
So, I'm going to ask you guys to walk us through what's going on with this project.
So I'll actually do that, I think. So what's going on in this prototype is we have 2 copper electrodes, and I'll actually kind of hold this up and show. 2 copper electrodes, and then dielectrics in between. And what happens is when the copper electrodes come closer together, say by like stepping on it, it makes the electric fields become closer and creates a potential difference, therefore current. So that's how that works. And then this is our theoretical model, and it does the same thing but on a larger scale.
Okay, nice. Okay, so I'm going to ask you then, what is the impact of this prototype? What's it going to do?
The impact is it'll be able to produce clean energy for a college campus like The Ohio State University. We predict that if you put it in the paths on the oval, it could produce $16.5 million worth of energy each year.
That's like to hear. So then, I'm going to ask you guys one more question. How do you see this actually being implemented at Ohio State? You know,
so the idea of how much it would cost to actually implement it is a difficult question. It's not something that we've fully investigated just because it would depend on a lot of existing circumstances, but we think it's more of a case-by-case basis. We need to analyze what the existing infrastructure is, and in places like OSU, you know, do we need to have some sort of on-site storage for the electricity that's being generated, or is there some facility that already exists that we can kind of feed it and store it there?
Nice. Okay. So my last question I'm going to ask, what was the best part about building this and this whole project?
Realistically, the best part was probably getting an actual voltage reading when we were testing it, and then just the building part of it, since we had to go through many days at the workshop, so that was probably the best thing.
Nice. Okay, you guys heard it here. It's a really cool prototype that they built. Thanks, guys. Appreciate your time.
Thank you. Thank you. Thank you.
All right, we're here with Team Z7 in the 128202 class. So, walk me through. What is the problem that you guys are trying to solve?
Our problem, so 27% of the world's population does not have access to clean and safe drinking water. So we wanted to find a way to bring that to them in areas that have are disadvantaged with money, and also maybe their electrical grid isn't on par with others. So if you look here, we have a map of the water scarcity. The darker the color, the more water scarcity there is, and then this is solar radiation. So we found a connection between water scarcity and increased solar radiation, and that drove us to the idea of using a solar still, using only solar energy to desalinate water.
Right. Is that what we have over here? So look at this cool prototype, and we're going to get a little bit about it. So tell me about the solution that you guys have.
Yeah, so this bulky thing right here, this is our solar desalination unit. It focuses around a parabolic reflective sheet, and what happens is the sunlight comes in and it bounces to the center. At the center is a pipe filled with salt water. The salt water heats up because of the radiation coming in, and it'll evaporate. Then a fan, which is right here, powered by the solar panel, push the vapor to the condensation unit over here. The condensation unit then, in these test tubes right here, the water vapor will condense, and then it'll drip down as fresh water. Nice. And then finally, you scrape out the salt.
Okay, that seems really cool. So you're saying it's functional?
Partially functional. It evaporated the water. The problem is, one, the testing conditions in Ohio are horrible for this because this is not where it's supposed to be.
The evaporated water, you could tell it was evaporating. It didn't condense any water, so we were very confused. Then, after investigating, we found out there's gaps in the wood up here, and steam rises, so when it went in here, we think it just escaped before it could condense.
Okay.
So future testing, we just fix that. We could do a lot of stuff to optimize this, but I won't get into that.
Okay, so with that, we're going to move on to how much does this cost, and what do you guys think if you had more money you could improve?
Okay, so our final design costed $228.50. This was significantly over our goal and more than comparable models at $150. This table over here shows a breakdown of our costs. As you can see, the 3D printing cost was $85, and our calculations show that if we were able to do this at a different facility, that cost could be cut down to about $10. So greatly decreasing the cost to very close to our goal. And then so far as material optimization, looking at this, we think an aluminum sheet would be good to replace this parabola because it's lightweight, cost efficient, and still reflective. And then also for this condensation unit, we definitely want a film that would seal it or a different material altogether just to not allow any water to escape.
Okay. Well, thank you guys. It's a really cool project, really cool output that we see from here in the prototype. So if you guys want to learn more, Table 12.
At this time, I would like to ask C2, E1, A2, and E9 to come courtside. We're down to the final four of the best of the best. This is what everybody came for. Course master, I turn it over to you.
All right, passengers, welcome to Brutus International Airport. You'll have 1 minute to set up your robot. Do everything except your final starting action. Give me a thumbs up when you're ready. Your 1 minute starts now.
Just push everything in and put it down. It is a tiny bit. It is within the circle. You guys give yourselves like 0.25 minutes. Ready? Cool.
This is the final round of the 2024 FEH robot competition. Do your final starting action now. Do not touch a robot again until instructed. Crouch or sit down and give me a thumbs up when you're ready. The kiosk button light is blue. The fuel lever is A1. The match will begin in 3, 2, 1.
Alright guys, for the live stream, you guys just won the 2024 FEH Robot Design Showcase competition. What's going through your mind?
Just so much relief and excitement. Like, we were so nervous prior to this, especially because we were on course C, which we had a bit of a rough time on in the round robin. We had to make some changes, taking this giant chunk out, but we managed to get it done, cross the finish line, and we're glad to be here.
Nice job, guys. Nice job. Congratulations.
Thank you so much.
For the award for the 4th place finish, E1. Good.
Yeah.
A2, if you could please join me. Congratulations on 3rd place. D9, please join me. Excellent. Thank you.
Got the new 15 that I wasn't going to use. It's shattered everyone, the entire screen.
And the winners of the FEH 2024 robot competition, C2, Laura Elson.
Good job, guys. Yeah, you guys can leave. You guys don't have to stay.
Alrighty. Oh, okay. So, we gave out the prizes for the competition piece, but we also had a ton of judged prizes, both for our other projects and then also still for the robot. So we are going to present those, and so I'm going to pass it over to Dr. Kadri Paris, who is going to announce the prizes for 1181 and 1182.
Thank you very much, Krista. We'll start first with engineering 1181. In first place, there will only be a first place prize for 1181. In first place, from table 26, all the way from the Marion campus, Team E. Put your hands together for them. The members of Team E from the Marion campus make your way forward to collect your certificate and prizes. Thank you very much. We now move on to Engineering 1182. In third place, from Table 122, Section 8130, please welcome Team N. Thank you very much. In second place, from Table 156, Section 8198, please welcome Team R. Thank you very much. And in first position, from Table 145, Section 8141, Team G. For the additional awards. We do have just a few more for honorable mention for really impressive projects that students have done in 1182 as well. We'll start with the first honorable mention, Table 163, Section 8239, Team E. Thank you very much. Next honorable mention will be Table 133, Section 8135, Team N. And last but certainly not least, we have our final honorable mention this evening, Table 152, Section 8195, Team K.
Engineering Innovation Award. Third place goes to Team B4. Thank you, Team B4. In second place, we have Team C8. Engineering Innovation, we have Team D6.
That's on the live stream.
Yo, Adam, finish your book.
Oh. Wait, bro, I'll take this.
In second place, we have Team Z8. Congratulations on getting to this point, and this concludes our event. Hope you have a good rest of your day. Thanks for being here.